for those who are not able to join us live, because it is something that we feel is important to make sure we have opportunities for people to go back and listen. Some of you may want to do that a second time. As I shared earlier, my name is Melissa Raspberry, and I work for the American Institutes for Research. I'm the PI, or Principal Investigator, for the National Science Foundation's funded ECS for All Teachers virtual community. A lot to get out in a quick time. That just means that I have the honor and privilege of working with amazing teachers all across the country who are teaching computer science, whether in high school or implementing the hour of code in their kindergarten classes. And I love this opportunity that I get to work with folks from all across the country. Tonight, we have one of our community ambassadors, Boyle Whyte, who is going to be presenting to you about strategies for implementing the ECS curriculum. As I understand, there's been some new changes to the curriculum and a few things that look a little different than they have in years past. And Tina's going to get into that with you with our special guest, Dan Rhode. In the meantime, I'm going to be in the background providing tech support and just generally being here to help in any way that I can, keep track of questions in the chat window, et cetera, so that Tina and Dan can focus on their presenting. But what I do ask that you do, for those of you who have connected already via your audio and either have a phone or a microphone connected, we ask that you make sure to mute yourself. Even if you're in a quiet room, many of you are still at school, or those of us on the East Coast, you may already be home, and if your dog or your kid or your husband or any of the above, all of the above come into the room, there's often that background noise. So we just ask that you make sure, we'd love to have you connected via audio, but we ask that you just mute yourself until the time comes to ask questions, and then you can unmute. To do the muting, you go up to the top of your screen, and I see a little phone icon and a little drop-down arrow, and I can click down there to mute myself. So I am going to do that myself momentarily, but at this time, I'm going to turn things over to Tina and look forward to hearing this wonderful conversation. So Tina, take it from here.
Thank you so much, Melissa. I'm excited to be here with all of you today to talk to you about strategies for implementing the ECS curriculum. And Melissa did mention that there are some updated versions, and if you have not downloaded the updated version, you can just go to the exploringcomputerscience.org website and download the most recent version. But I'm excited to be here as one of your community ambassadors for computer science. Tina Boyle Whyte, let me tell you a little bit about who I am. I live in Pewaukee, Wisconsin, in the Milwaukee, Wisconsin area. For many of you who may not know where Pewaukee is, I am a product of computer science and the work that has been done with Marquette University to expand computer science to students and to teachers across the Wisconsin area. And I was in West Allis Public Schools when I first became a computer science teacher. I was a business teacher at first, working in my classroom, implementing a business curriculum where I integrated some graphic design and some HTML and some other things, and I had the wonderful opportunity to come across the ECS curriculum. And I implemented it with fidelity in my school, and some of the learning lessons that I had as a result of that I want to bring out to you tonight. Currently, I'm at Marquette University as a full-time faculty professor teaching Introduction to Software Development, but I'm working with teachers who are continuously implementing this ECS curriculum and curricula such as computer science principles and other curriculum as we work with teachers at Marquette University to implement professional development for teachers just like yourself who's listening today. But today is no different. I have Dan Rhode, a special guest with us tonight, a colleague of mine, and I didn't share that we at Marquette University, we provide professional development for all of our teachers that we are moving in this process. And ECS, Exploring Computer Science, is one of the curricula that we have implemented as a statewide. We do We do professional development in the summer, and then we have quarterly professional development, as well as we have professional development virtual meeting, virtual classroom once about 6 times a year for our community that we have raised up. And tonight, I am really excited to introduce to you Dan Rhode. And before I do that, I'll have him say something. I want to just tell you what Dan Rhode and I are going to have a conversation about tonight is exploring the curriculum for the entire year. So be thinking about it. Pull up the curricula on your computer, and we'll work through it. We'll be examining critical components of the curriculum, and then we'll discuss implementation strategies. And Dan Rhode, he is an educator in Baraboo, Wisconsin. I'll let him say a little bit about himself. But the most important, you have the best with you on the line, one of the facilitators who have had the opportunity to meet. I'm not sure if you met Jane, but I know you met Gail Chapman. You met the leaders who are doing this work. And this is, we'll talk a little bit about this book, and we'll talk about the curriculum as we go through this, this whole process of implementing strategies on tonight. Dan, welcome to the webinar.
Hey, great. Can you hear me okay?
I can.
Perfect, perfect. It's an honor to be on with so many great educators. So thank you for giving up your nights to join us and listen to me ramble on about something I really believe in, and that's exploring computer science.
Oh, such a pleasure to have you, Dan. Anything you want to share with the teachers about what it is that you've done with exploring computer science? Because I know you came from a different background. So tell the teachers just a little bit about yourself.
What I hope that people can glean from my background is that I am not a computer scientist with a master's degree in computer science who programs day and night in assembly. So I was a special education teacher for over 20 years and got the privilege of switching careers. Computers and geeking around have always been hobbies of mine, but being able to switch career and be able to teach my hobby, fishermen across the world are jealous of how I could turn something I do for fun into a profession. And it's a real blast. And I hope tonight, like in my classroom, you don't have to be the expert on every topic. The beauty of computer science and the way ECS approaches computer science is that you don't have to be an expert in every topic. You just have to create an environment where people want to share what they do and get better at what they do. And I really enjoy ECS and hope to share that with all of you. I'm curious about the backgrounds of the people in the room as well. It would be great to know that before we ramble too much into what we do, so we make sure we hit our target audience.
I agree, Dan. While they're typing in, we'll be able to scroll through and see who's here with us and to see what levels they're teaching at. That would be awesome to know. And I want to share with the teachers on attending tonight. We do have Amy Fetherston, another Wisconsin facilitator online, and she'll be jumping in and out at the point. She also teaches exploring computer science in another school district in the Wisconsin area. So this will be a rich conversation for those who are here with us tonight. And so as they're typing in, maybe we can look, oh, okay, so we have math teachers. And so I'm glad that you said that you didn't come from that background, that, the way this curriculum is set up, anybody can implement it because of the intentionality of the authors of this curriculum. So without delay, let's do some of the kind of the information that I want to share, and then we'll kind of work through the curriculum and we'll see where the teachers need help. Okay, so Dan, we'll make this a conversation, okay, as we work through the slides. So 3 of the themes that really come out in teaching or implementing this curriculum is the creative nature of computing. This curriculum really brings out, and Dan, you could jump in at any time after I say these, the curriculum is really designed for us to understand the nature of computing. Technology as a tool for problem solving. that's something that was intentional in creating this curriculum as well, and the relevance of computer science and its impact on society. Dan, share with us as you've known the authors.
Right. Another really cool part of that is that it doesn't do it the way I was taught to teach 100 years ago. It doesn't give the kids a lecture on the history of computing. The definition of computing is a device that takes an input, processes the input, and provides output. The data is somehow stored, and the device is artificial. You don't teach like that and then ask the kids to regurgitate it. What you do in the curriculum, in the very first lesson, is you ask them how many computers are in the room, and you set up a situation where they get into a fight over what their numbers and how many computers there are, and they realize they need to define a computer, and then they discover the definition of computer by trying to figure out how many computers there are in the room. The curriculum is very creative and deliberate in the way it forces inquiry and forces the students to wonder about things rather than regurgitate things. In the age of Google, we don't have to obsess on students having memorized content knowledge, but what we do want to do in computer science and every field, I would argue, is create the ability to wonder and solve problems. And this curriculum, from the first lesson to the last, does an excellent job of facilitating that.
And you know what, Dan, I'm so glad you said that, because that's where we're going to next. And so as we look at the units, and you really hit one of the very first lessons, you want to walk through the curriculum as it is stated on there and just kind of highlight each and what you know to be existing in the curriculum as it is reflected on the slides.
Yeah, the curriculum is broken up into a number of units. And the first two units have a lot of unplugged activities, and the students aren't on computers daily in those first two units, where they're learning how computers work. They're doing a lot of activities together that deal with what computing is, what computers are, and learning how to problem solve in a bunch of really fun problems that actually lead them to more advanced computer science concepts, but they don't even know they're learning computer science while they're doing them. For example, in problem solving, they build a tower. They have to build a tower to 100 as quickly as they can. And a linear solution would be put one block on top of another, taking 99 weeks to build a tower of 100. But they soon discover a binary solution where they use the powers of 2 to build that same tower to 100 in 7 weeks. And almost all the groups come up with it. And even the groups that don't come up with it, you then turn the lesson to what were the steps you went through, and you discover the problem-solving model, the 4 steps the groups went through to solve the problem, teach the problem-solving model. But you never once teach binary search in that lesson, yet they learn about the power of binary search, and you can refer back to it later in other classes. I refer back to it in my CSA class when we're doing binary search. I say, remember when you built that tower in 7 weeks and you were like, that was amazing. That's the difference between a linear search and a binary search. That's the power of log-based 2, and that kind of concept can wrap back around. And the units 1 and 2 are packed with lessons like that. And it's really fun and engaging and involves a lot of group work. And it's very powerful for when you get to units 3 and 4, which are, I would consider, a fundamentals of programming unit, where you learn to type HTML, CSS, and JavaScript into some kind of tool to create web pages, and learn that code stuff you write converts into the way the world works and converts into web pages. And then you use an amazing programming language called Scratch, which is a very simple to start language, but a very powerful language. Even students who take CS50 at Harvard, which is where Harvard students start their first week in Scratch. So we're using a powerful, common programming tool that teaches the basic principles of programming in a very accessible way, where you click, drag, drop blocks of code, and it's a great way to start. Then units 5 and 6 are what some call the applied units. Those are the units where you apply the skills you've learned in getting along, working together, and solving problems, and the coding skills you've gained to do some data analysis and some engaging projects that some students really get into, and the robotics unit, which depending on your setting, there's a variety of options, and the students love building robots and doing the robotic challenges provided by the curriculum. So lots of really cool opportunities.
It is an amazing curriculum. As we look down at the bottom, I know that it says the social impacts of computing. It should be integrated in the curriculum. So it's not like a unit that you take and you implement it. But if we were to look at a time chart and we looked at like today, like October 17th, you know, at this point we should have already covered human interaction over the 4 weeks, and we would be right in the middle of the problem solving, which would probably be ending, the third week if you started school August 26th. So I'm kind of projecting that people started around that time. And then after that, if it's a full year, and so we'll talk about people who don't have a full year implementation, and be thinking about that, Dan. And I have some questions that I'm stirring as we're talking as this move along. But units 3 and 4, which are very fun units, the whole curriculum is really fun. But unit 3, it'll take 5 weeks. So I kind of projected kind of taking that through the Thanksgiving holiday time, and then 4 kind of stretching over. So that's my projected time frame, but it can change. It was just me projecting what is possible, and Dan, you can give some real life how you deal with that, and we'll come back to that. Is that okay?
Absolutely.
All right, and so as we're moving along, if you had that timeline, that would be something that you would use. I want to talk about the structures of the unit, how each unit is set up. And so they describe that their units are set up such that it'll begin with a description of the topic, an explanation of the importance of the topic, possible social applications of the topic, and objectives for the unit. So that's how the unit is set up. Do you want to talk about that and what the lesson day by day, without actually going to a lesson, how does that flow, Dan? Talk to us about how does that flow?
The way I describe it is it's really tricking the kids into learning. You do not, I don't start any lesson by saying, today we're going to cover how networks work. What I do is I introduce it. We are going to connect all these roads in Muddy City. So the lesson is, from my training way back in the Stone Age, is flipped, where we're presenting really engaging activities that the students completely, in my experience, buy into. And then we flip it at the end into, look at how this is connected to computer science. And we often, I should say every lesson, sometimes lessons go over multiple days, but every lesson starts with a journal prompt that is related to the topic. So at the very beginning, we might have a journal prompt that says, what are some examples of things that are networked? And make a list of as many network things as you can come up with. And students will come up with everything from air networks to computer networks to social networks. And then you'll have a lesson like Muddy City, which will be really engaging, and they'll discover the minimal spanning trees. In other words, connecting the shortest connections first to build a network so that you can be the most efficient. And then you'll end the lesson by bringing it back by, isn't it interesting how we created what looks like that we have these nodes and these connections? Isn't it interesting how similar this looks to a network map? And it leads students very well through computer science concepts, but tricking them because they're really engaged in the unplugged activities.
And Dan, you've said unplugged activities. Just for somebody who might be listening, give me an example of an unplugged activity, because we're talking about the unit structure, and we're talking about the lesson plans, and sometimes it'll say unplugged, and sometimes you'll be plugged in. Kind of explain what that is.
What unplugged means is that I teach, and there's an actual website, the Unplugged CS, and what you're doing is you're teaching computer science concepts without the computer. So, for example, when I'm teaching search, or I should say the ECS curriculum, so I feel like I own it, but I just work here. When I'm teaching search or sorting algorithms, when I'm teaching sorting algorithms, I have different weighted, I put them in film canisters, but different weighted amounts of materials, and I set up the exact same rules that a computer has to follow to sort, as far as only being able to move one at a time. They don't realize that they are sorting items in an array, and they're learning that there's a difference, that there's bubble sort and insert sort, selection sort, and merge sort. They're not learning that stuff. They're trying to solve a problem with how to get these in order, following these crazy rules that don't seem to make any sense to them. But the rules lead them to discovering these sorts, and it's so exciting to then tell them, you just figured out a bubble sort. And I don't know how long it took computer scientists to figure out bubble sort, but you figured it out in 20 minutes. You're pretty darn amazing. You're good at this computer science thing. So they are never on the computer writing a sort algorithm. But what they're doing is, with these weighted film canisters and the rules provided by the curriculum, they are figuring out how to sort these items into order. And in doing that, they are discovering an algorithm for, usually bubble sort is the one, or insert sort. Those are the two they seem to generically find the most often. They find. And it's a lot of fun to teach that way. And it creates that sense of wonder and inquiry and a confidence that they've got this computer science thing. They can do amazing things.
Wow, that is so exciting to really, as a teacher, having the opportunity to teach this to students is just amazing. And you can have so much fun in so many ways in this curriculum. I want to talk a little bit about the computational practices. And so there's 6 computational practices. And Dan, you talk about these a lot when you're doing the professional development over our 1-week PD training that we have with teachers. Do you want to bring that out and talk with the teachers who are online? How important is computational practices when they created this curriculum? Talk about it, what their intentions were.
The computational practices not only are important in exploring computer science, but they're important in all computer science courses. And you'll see these almost identical practices in CSP. You'll see them a little more limited in CSA, but CSA tends to especially de-emphasize communication and collaboration, unfortunately, but unintentionally, but that's just kind of the way that course flows for me. But what these practices are what you do in your classroom, and what I like about this is I don't say to my class, today you're going to design and implement a creative solution and then create an artifact for it. What they do is they discover bubble sort, and then they have to make a poster on a piece of butcher block or a big Post-it note that explains the algorithm so someone would understand it without having been in their group. While the teacher talk is design and implement creative solutions and make an artifact, the reality of it is tons of fun, and the curriculum just makes it real easy to do that and real intuitive to do that.
Number 3, are you going down one by one? Number 3?
Yeah, did you want me to talk about each one?
Yeah, yes, could you?
Oh,
yes.
okay.
Yes.
Once you get me started, I'm kind of dangerous. Sorry, everyone. When you analyze the effects and development in computing, the example that pops right to my mind is I go and ask each student, what is your problem? And they're required to make a slide deck. This is the way I implement it. There's other people who implement it differently. But they have to find a problem in their community, a slide deck, and then have one slide for identifying the problem, one slide for planning a solution. Oh, I missed a step. Understanding the problem, planning a solution, and then reflecting on it. So they need a slide for each of those. And then I get the joy and pleasure of saying to each student, what's your problem? And they'll say, my problem is there's too much plastic going in the garbage and not in the recycling bin. And so they'll use the problem-solving model to identify a problem and solutions that can come with that. Those who teach CSP might recognize the similar thread to the Explore performance task, and how by doing this in ECS, we're really preparing them to identify a problem for the exploring performance task, where they have to do a similar process just at the college level and more depth. So, and the artifact it has to be a computational artifact instead of just a Google slideshow that I kind of structure for them. But the next design and implement creative solutions I already did. Oh, abstractions and models. Going back to the example of the tower, we start them building that tower of 100 with a Lego stack of 10, where they have a model of a Lego stack of 10, and then they create an abstraction for creating the same structure 100 tall. Analyzing work, the example I can think of is the constant way we ask students to give feedback to each other, which we often don't do in a lot of courses. So whether it's gallery walks or reflecting on other people's journals or making comments on other people's work, and teaching them explicitly how to do that. I foolishly discovered when I first started teaching ECS to students that they didn't always make nice comments, and they often made very surface comments. They would go to every computer and say, "Cool dude, cool dude, cool dude," and I would have wasted a whole Post-it notepad with cool dudes. So it's teaching them how to give that specific feedback and how to communicate with each other. The curriculum does a great job of doing that. The communicating computational thought process, procedures, and results to others is more subtle, but it happens a lot in the group work. So inside of the groups, when they're trying to figure out how to solve problems, they have to communicate their solution to other people, and they have to figure out how to communicate that same solution often to the large group. So they may come up with a solution for how to build a tower in 7 weeks, for example, but they also have to figure out a way to make a poster for that and then explain it to the group, which is that process, even though it sounds intimidating, in practice it's really fun and engaging, and constantly the kids are collaborating. I also mix up the kids when they're unplugged, and they're unplugged often. So when they're plugged in, they got to kind of be on their same computer because we have login and accounts, and it takes forever to transfer accounts. But when we're unplugged, almost every time they're unplugged, they grab a card when they come into the room, they roll their eyes, and they look at where the card tells them they have to sit, and they're in randomized spots and have to start by doing some kind of really fast, easy icebreaker activity, and get to know the other people in the room. So they're constantly collaborating, and not only collaborating, but collaborating with different people.
Dan, I love how you make ECS sound so exciting, and it is exciting teaching as a teacher, and this is what I want, and the reason I'm going as an implementation strategy over these things, as you talked about the curriculum, it really shows everything that the students are getting and the intentionality around what the authors did, and so the curricular approaches that they used is very creative, very collaborative, as you were talking about it, very interdisciplinary, very problem-solving focused, very inquiry-based focus, real-world computing problems. I like how you raised the point about Muddy City, and it says the mayor needs to figure out how to use the shortest steps. That Muddy City one brings it to real life, as well as the tower one. Culturally relevant, and we'll talk a little bit about that in just a short few slides as we move along. And then social and ethical exploration. Do you remember which part of the curriculum where we looked at some social and ethical implications of, computer science? Anything come to your mind? There was a video that they had early on. I'm not sure if they changed it or not, but yeah, we look at social and ethical implications. Anything coming to mind, Dan, that we really focus on?
In each unit there's something. And in the first unit, there's the whole rise of AI, Moore's Law. Also, it's not in the curriculum, but it's real compatible to introduce them to Kurzweil and the singularity, which I do to try to blow them. You can also introduce them there to the, the Elon Musk multiverse theory, all that kind of stuff. Kids love to debate and sink their teeth into. You just have to start it with the opinions reflected here, not necessarily those of management. But it's
the disclaimer.
And high school kids love to have their minds blown like that. So
they really do.
Yeah, in Unit 2, they come up with a community problem, and obviously you're trying to hope that they, I had one kid who, we're in the middle of that unit, and one kid's problem was it's so hard to get like the pickle jars open these days, and I wouldn't take that one because that's not a, there's no social, that's a major problem, but let's come up with something that has a little more gravitas, something that's a little more, you can think of a bigger problem. I know you can. And that kid did end up coming with a bigger one. The third unit in the web unit. Yeah.
Yes.
I'm sorry. This is Melissa. I just want to jump in here because I think a statement from Lisa in the chat window has some relevance to what you all are talking about. She said that they're wanting to add some courses to their school next year, and they'll be teaching CS for college credit, but also wanted to offer something for all levels of students. And I know that from what I understand of ECS, it really was meant to be to ensure that there was more equitable access to computer science for perhaps the non-traditional students. So and when I say non-traditional, I mean those that hadn't been encouraged to take classes in the past. And that, I think, kind of gets into a lot of what you all have been talking about in terms of how the intentionality of how the curriculum is set up. So I was wondering if you could maybe talk to that a little bit and how you've seen that students who might not have been quote unquote ideal, and I'm putting that in the world's terms, not necessarily in our own, the ideal candidates in a computer science class have been able to benefit from this ECS course.
Dan, you want to speak to it? Even though you're in a very remote area, you're in a remote area. Amy, if you're online, you can jump on. Amy is from a suburban area. I taught in the urban area. And Dan, you're in the, I would call you rural. And we could consider girls, because girls could be in that category, and black and brown students or anybody in that category. So we'll start with rural first.
Well, what's nice about ECS is it's not, what ECS is it's my recruiting class. So the ECS class brings in a lot of students. It's not intimidating. It's got a reputation from students for being really fun and not a tough grade. So it brings in a lot of students, and in the rural community, word gets out. And so it's not exploring computer science. It's that class, well, everyone calls me Rhode. It's that class Rhode teaches. So that's the word, that's the way we recruit students. And the students discover they're good at computer science. They're not doing tons of math. They're not doing tons of programming. They're discovering they're good at it. And then that allows me to steer them to the next level, which in our school is APCSP, which is an advanced placement college level course. So in the rural area, a lot of our recruitment is done by reputation, and this course makes it easy to have a good reputation for having a lot of fun activities, because there's a lot of fun activities embedded in the curriculum. That's a great question.
That was a great question. I agree with you, Dan. And Amy was typing. I don't know if, Melissa, can Amy unmute herself and talk? I'm just wondering. She said ECS is definitely the most diverse class I have ever taught. And she's in the suburban area. And Melissa, hopefully she can unmute herself and we can hear her, but if not, I agree. I was in an urban school district, and that class offered the opportunity for students who were not normally tracked for computer science to come in. I had African American girls, I had African American boys, just diverse, just like Amy said, and Amy, if you was able to be on the phone, Melissa said we could hear your voice. So maybe in the next, the time is really going really fast. We have 25 minutes, but we'll open it up. And I just want to hit some few things. But Lisa, great question. Diversity, get it out. Let the kids know it's fun. It's fun for you as a teacher. You have a guide, and it's just a great course to just get students tracking in the computer science track. So thank you again for that question. I wanted to, I just got a few more slides, and these will be quick. The pedagogical approach, very important. The most important thing that when you look at this curriculum, it was for creating ambitious, meaningful tasks, and the curriculum does that. Engaging students in active learning, the curriculum does that for sure. Drawing connections to students' prior knowledge and experiences, and that's where, you know, that whole, the diversity, really drawing from a multitude of students' experiences and valuing all voices and equity. And we didn't talk about that, Dan. Just kind of key up for equity. We'll do that in a second. Scaffolded learning, definitely in this curriculum, you will scaffold and build on. Dan has talked about it already. Assessing students' learning continuously and adapting. You know, you're always adapting. And for those teachers out there that said, I can't, you know, sometimes even saying, I don't know, as a teacher in this curriculum is very, it's just great. You know, I don't know, what do you think? I don't know, what do you think? And being okay with that as a teacher. Providing clear standards, having constant feedback and opportunities to work for students to work together, and encouraging strategic and metacognitive thinking, you know, having the students thinking about their thinking. So it's really, really exciting. Dan, anything you want to say about the pedagogical approaches?
My favorite part, again, is how it feels accidental. It feels incidental. All these things happen, but often in my previous teaching experience and working with other curriculums, I felt like it was so forced. Everyone be creative right now. The morale will improve, the morale will improve, or the floggings will continue. You know, that was kind of the approach. Instead, with ECS, the approach is you just did this silly game where you sorted the containers of different weights, and all of a sudden you discovered a bubble sort. You know, that approach is just fun for students at this age, at this high school age. There are also lots of big ethical debates and discussions that typically start in the journal and often wrap up in a reflection at the end. And they're tons of fun, and the students are really engaged by it. It's not all about the details of Boolean logic. We'll save that for CSA and data structure.
Yes.
But these other things are just really exciting and interesting and engaging. And computer science isn't only coding. Computer science is a very broad field that involves a wide variety of disciplines. So I love the way ECS touches so many of those.
Oh, thank you so much for sharing that, Dan. And as we were talking, you know, very important to know teaching strategies that you get to use. Kinesthetic activities, movement, the daily assignment, final projects, real-world problems where they're socially relevant issues, and then a lot of collaboration, which you've already mentioned, Dan. Some implementation strategies, as I think about it, you know, you get to experience with multiple strategies. You have communication tools that, you know, the students get a chance to experience. You mentioned journal entries, blog entries. They do a lot of peer reviews, especially with the Post-it notes, gallery walks, which is something else, jigsawing, role-playing, and collaborative grouping. And so those are all things that you get to do in your classroom as a teacher, those wonderful teaching strategies. And the skills that the students earn or gain is just endless. Communication, the written skills that they build on is journaling, academic writing, letter writing. The curriculum allows for that. They definitely have the opportunity for oral skills. In computer software development, like those skills that they get to develop with the HTML, with MIT, the Scratch, storyboarding I think that's for HTML, animation is with HTML, and then just the collaboration overall. I mean, there's so much. Dan, what would you like to share with what I shared about teaching strategies, any other strategies, and what the students get as a result?
Again, there is a lot packed into that course, and they do program, they do code. Your geeky kids are happy. But in addition to that, there's a lot of non-coding activities that students are involved in, And it just really hits a wide variety of students. And that list is very comprehensive. Even English teachers are impressed with how much journaling our students do. Even math teachers are impressed with how they apply math. It's an amazing program that reaches a wide variety of students.
Wow, wow. I know we have a question coming up, and I just want to jump to the potential hurdles. And Kathleen, I see your question. You're curious about explicit teaching of collaboration and communication. I know the curriculum builds on this, and wonder how have you taught this besides just building on the experiences. Also wondering the same about explicitly teaching students to reflect well. Dan, is there anything you want to add or say in response to that? Explicit teaching on collaboration.
Go ahead, Melissa. I would also say
about that one too. A couple of things that I do, and sometimes I wonder, I'm not as sure if this is in the published curriculum or just the materials that are available online. But one of the things I do explicitly in the beginning is use a rubric for group work and say this is what a good group looks like, and this is what kind of person in group are you. And one that I remember off the top of my head is the rubric related to leadership. Are you someone who sits in the back? Are you someone that contributes when someone gets you started, or are you the one who gets things started? So where are you, and where do other people think you are? And so there's some explicit opportunities for students to talk about these things, and it doesn't mean everyone has to be a leader. In fact, it's bad when everyone's a leader. So it gives you wonderful opportunities to talk about those specific skills, and I think that might be off their website. The CS for All website, I think, is where I might have gotten or been involved in that rubric. But there's a lot of really good opportunities for collaboration, and when in the PD, we focus on that a lot. In fact, and it would joke in the PD that you never sit with the same people for longer than the next break. So don't get too comfortable. Don't put all your stuff in one spot, because you're going to be moving next time you have a break. So keeping that rotation going in your classroom too is really helpful in collaboration and preventing those cliques from forming, and teaching some genuine leadership and collaboration skills. We also do explicitly in the curriculum, there's the coder and the pilot, co-pilot, coder, co-coder roles that are explicitly taught. You can touch the keyboard, you can talk, then you switch, and that's an example too of collaboration.
And so it's that whole piece, Dan, that you're watching the students, you're walking around, and you're making sure they do that. I wanted to say, and this is our last slide, and we have 2 minutes. I'm going to take 2 minutes. Potential hurdles. Implementation fidelity, sliding out and not following the curriculum as such. Timeline implementation, if you get off track, I put the timeline on. That could be some hurdles to getting through the curriculum. Or even if you get frustrated in a certain part of the curriculum and you just skip over it, there's some critical parts as we talk about equity and cultural relevance that a lot of people in the professional development course session that we do, they get uncomfortable with the cultural piece, and we could talk about that if somebody raises a question, or if they don't raise a question, we'll talk more about that, Dan. And then local application, really knowing, is your course, is it one semester, is it a tri-semester, is it the whole year, do you flip students one semester or not? So those are all potential hurdles to this whole curriculum. And we could go, unit by unit, but we don't have time. But if people have questions around this curriculum, we'll take them now. And please open up your mics and talk to us. We want to hear voices. We are at 16 minutes or so. Somebody's mic is unmuted, and I hear background. So if your mic is unmuted, can you mute your mic so that we don't hear your background noise? Okay, so
Kathleen? pause just a second, Tina. Kathleen, I know you put a couple of comments in there. We would love you. I know your mic is connected if you'd like to voice those audibly so we can hear from you and can provide a little bit more context. Just remember to unmute yourself first.
I think you can hear me.
Oh, we got you now. Go ahead.
You have me now. Dan did a great job of answering my first question about teaching collaboration. I've implemented some ideas, and I'm just always looking for other ways to really build that, because I feel like it's a continued challenge. Alongside that is teaching them to reflect well. They tend to want to really just take a shortcut, like, oh, my solution was different than the other person's. I got a different answer and had different steps, period. Which is not a deep reflection. So just curious about how you continue to promote that.
Dan, did you want to do it?
Yeah, silencing me is the struggle. Kathleen, that is so high school student. We work with the same kids. I so agree with you, and I completely see that in my students too. And the way I try to do that is that art of teaching thing, is to turn it into an argument where they have to defend the way they did it. And once they're kind of defending themselves, I found that kids often will engage and want to explain why they did it the way they did it. And so I found that to be helpful. I also like to do those things like equity sticks, and all my kids at the receipt, they have a card, like a playing card, so they're at the ace of spades or whatever, just randomly picking a card out and seeing what, and getting an answer is highly effective, especially after you say, okay, I want your group to talk. I'm going to randomly pick a card. You don't know if it's going to be you. And then there's often great collaboration for those few moments of panic where everyone fears their card is going to be drawn and they want to have something to say. So just a few tidbits of things you can do. But the struggle is real, Kathleen. It's not just your students, and it's not the way you're teaching. It's the developmental level those students are at. I'm confident, because if it's your fault, that means it's also my fault.
So I also really appreciate, and I think this is something, at least for myself, I feel I constantly need to be reminded of, is the equity piece, because I have a tendency to think, oh, they need to know this computer science terminology or approach. So I really appreciated what you said about kind of backing into it, so they discover it first. And that was, I feel like, a really good reminder for me, and I think the curriculum really approaches it that way. So it's really powerful for, I mean, I have all black and brown students and a lot of girls, so they don't have any background. So I love that statement. That was a great reminder.
Kathleen, how do you recruit successfully so many diverse students?
This is the very first year that we had ECS, and they were required to take it as a math course, the 11th and 12th graders at the school. So I'm putting a lot of the fun posters that they do out in the hallway to kind of create a buzz around the class, so that next year, when it may or may not be required, that everyone will want to take it, like just to start it, with the younger grades.
Very well done.
That's very exciting. Very, very great to hear, Kathleen. Great job. Are there any other questions? Melissa, do you want to kind of facilitate that? And if no one gives questions, we can jump in. Dan and I can talk about something for 5 more minutes, and we go from there.
Let's see. I'm going back through our chat box here to see if there are other questions that we have not gotten to. Just a moment.
Then if there's no other questions, what might be some implementation challenges that people might be dealing with? Please chime in. We have about 10 minutes. We have the expert on the line.
Is the latest version 9.0 or 8.0?
Yeah.
What?
9.
Okay.
9.
Great.
Sorry, I
There's
also
cool supplementals now. There's a really cool e-textiles unit that you can add, and there's a cool artificial intelligence unit you can add into the curriculum. They suggest it at the end of the curriculum, but they're available. They're in the ECS style of that journal, discovery, inquiry, equity from the start mindset. So they're excellent lessons, very well designed, that you can add if your students or your situation promotes, for example, e-textiles or AI. You have a bunch of students who are really into that. So it's really cool to have those options and those supplements out there.
So with those options, they would take the place of one of the last units, like instead of robotics, right? Because there's not time to do all of that.
Right. A common thing I hear or I've heard out when facilitating is that we can't afford robots, which is the expense, is undeniable. So sometimes some alternative activities, and there are like virtual robots, but to me, what's the point of a virtual robot? The whole robotic thing is that hands-on. When you write code, it actually implements it in the robot in the physical world. But there are options, and not everyone's school year is the same. So it's always good to have options. I'd always rather have too much material than not enough.
So with the robotics units, because this is the first year I've taught this, I don't know about other people. You can do that programming with Chromebooks, I'm assuming. Do you know?
If you're using there's different types of robots. So the robots currently recommended by the ECS is the Edison robot, and the Edison does work with Chromebooks. With anything involving technology, you have all that fussiness, but it is really cool the way they connect and they work together. We actually have a Edison Chromebook expert on the line here, and Amy. She's really, really knowledgeable on that. And if you have a specific question, want to toss it out, like I said, we have Amy here, and she can really give a detailed answer.
Amy, if you're on the line, please type in. I'm sorry. Go ahead. Mm-hmm.
Sadly, I'm not there yet. I don't even know what questions. I don't even know what I don't know yet about Edison robots and Chromebooks. So to be continued.
The kids will figure it out for you.
Yeah.
And then they'll be using inquiry. Rather than you giving them a lecture, this is how you do it. It's way more powerful if they discover it. People still have Columbus Day as if Columbus discovered America. The power of thinking you discovered something is pretty potent.
Yeah, yeah.
Has anyone used the Lego robotic unit? Did you do Lego, Dan?
Yeah, I was lucky enough to, in my job, inherit Lego Mindstorms, which are incredible, but they're super expensive. They're I don't know, $400 a kid or something ridiculous like that, and you need like 1 kid per 3 kids. So it's an expensive. It's expensive, but they're awesome. Vex, I see in there, is an incredible platform. We have a competitive robotics team that uses Vex. It is a wonderful way to do that. And the activities are pretty agnostic. So the things you can do with the robots, the platform isn't as important as the experience. So you could do that with all kinds of different tools. Samsung tablets, I'm a huge fan of those. I also use MIT App Inventor in a different course, App Design. And depending on the power of those, you can do some pretty amazing things. What's cool about like the Edisons is they connect via a sound port, so that you don't even need that USB out, which some Chromebooks don't have. You literally plug in where you would plug in a headphone, and that headphone jack plugs into the Edison robot, and it talks to it through the sound channel, so it's pretty cool.
Wow, that sounds exciting.
It's very well done. The middle school age, I'm a former middle school teacher. I did a lot of special ed in middle school, and if anything's doable by your middle school kids, robotics is. But you have the constant challenge of the age of middle school, which sometimes ECS was designed for high school, so a lot of the discussions, debates, topics might not work as well with middle schoolers, as they tend not to be as reflective as like a high school student would be, but they're definitely doable. It's just, you'd have to make modifications based on the age level, which you'd have to do with any age level or any group anyway. So, but yes.
So I have a question about the website design, Unit 3, where you were talking about code programming or pair programming, and I just had today tell me, she's like, oh, she's so excited to make her very own website, like just for her. And so I'm wondering how you navigate that with students who really kind of want to do their own thing. I mean, I know there's the collaboration thing.
Yeah, and it is collaborative, but everyone's doing their own thing. So while one person is I do a pilot, co-pilot, while one person is doing the typing on the page and the second person is helping, they're developing and maybe fan page, for example. If you're working on that fan page, I call it the iFan page because, I added to anything is super cool. So when they're working on their iFan web page, the person on the keyboard is the one whose web page it is. And then when they switch roles, they're working on the other person's web page. So they're still each working on their own individual project. They're just working on it together and collaborating. But they don't have to both be into Doctor Who. One of them's into Doctor Who, and one of them's into, I don't know, something else, Battlestar Galactica, or whatever the geeky thing they're into is. Oh, and sorry, in my area, the Packers. So you have that Packers group, or that Packers kid, and you have that Doctor Who kid, and they're helping each other with the website, but they each still have their own website.
Oh, got it. That's super helpful. Thank you.
Well, Melissa, we're going to turn this over to you.
Thank you so much, Tina. You and Dan have been fabulous, just as I predicted. Thanks to all for joining us tonight. We are going to be closing out shortly. I am going to put the link in the window in the chat box where you will be able to find both the slides and the recording. That will be added in a couple of days, so you can check back there to get access to that information on the CS for All Teachers site. We're glad that you joined us, and as I put into the chat box, we'd love your feedback. I'm going to paste that information again, and just thank you all for being here. We're glad that you could join us on this Thursday evening. Take care, everyone, and good night.